Hello everyone. Take down next example, that is the show that integration 0 to infinity x to m minus 1 plus x to n minus 1 divided by 1 plus x to m plus 1 m plus n into dx is equal to 2 beta of mn with condition mn must be strictly greater than 0. Okay, see here it's a we have to using here third property, that is a beta of mn is equal to what? Beta of mn, using the third property, beta of mn is equal to integration 0 to infinity x to m minus 1 divided by 1 plus x to m plus n into dx. And also we know that by the note, I will explain in previous class, by the note beta of mn can be defined in the form of integration 0 to infinity x to n minus 1 1 plus x to m plus n into dx. Adding both, we get what? Integration 0 to infinity, the numerator x to m minus 1 plus x to n minus 1 divided by 1 plus x to m plus n into dx. Beta we get a 2 beta of m plus n. Okay, so this is the solution of the given example. Okay, take the next example. Prove that integration 0 to 1 x to m minus 1 plus x to n minus 1 divided by 1 plus x to m plus n into dx is equal to beta of mn, where mn both are positive. It's a very important question. They will ask more time. It's a 5 marks question. Okay, so here previous we have to prove what? Integration 0 to infinity x to m minus 1 plus x to n minus 1 divided by 1 plus x to m plus n into dx equal to 2 beta of mn. See here, the limit is 0 to 1 for our example. Previous is 0 to infinity. Don't be confused. If the limit is 0 to infinity, we get a 2 beta of mn. The limit is 0 to 1, we get a beta of mn. Okay, let's see the solution. Beta of mn is equal to what? By the definition, by using the third property, beta of mn equal to what? Integration 0 to infinity x raised to m minus 1 divided by 1 plus x to m plus n into dx. Okay, but we have to prove in the form of 0 to 1 with addition. That's why I am taking splitting the integration 0 to infinity into 0 to 1, 1 to infinity. Okay, we get 0 to 1 x to m minus 1 divided by 1 plus x to m plus n into dx plus 1 to infinity x to m minus 1 divided by 1 plus x to m plus n into dx. If you add in both, we get once again the limit is integration 0 to infinity. Okay, the first term, see, in first term you have a got a first term. What about the second term? You have to, the limit must be in the form of 0 to 1. That's why I am taking second term from the RHS. See here, we have to show the limit in the form of 0 to 1 and 1 it is in the upper limit, but in our second term we have in the lower limit. That's why I am taking, put x equal to 1 of the another variable, we get a 1 divided by t. In the reciprocal I am taking. Then what is the x differentiation? We get a dx, then 1 by t is a minus 1 by t square into dt. Once again we know that if you change the limit, the integral limit is also change as you change the variable. Then the limit is was x 1 infinity. I am taking x equal to 1, we get a t equal to also 1. If you take x equal to infinity, we take it 1 by infinity is a 0, that is at t equal to 0. Apply this value in the second part of the RHS. That is we get integration 1 to infinity x to m minus 1 divided by 1 plus x to m plus n into dx can be rewritten in the form of t. We get a 1 to infinity limit can be changed into 1 to 0. Then x value is what? Put that value 1 by t raised to m minus 1 and 1 plus 1 by t raised to m plus n, and dx value is what? Minus 1 by t square into dt. Okay. Next, solve denominator. Take LCM is t. We get a 1 t plus 1 raised to m plus n, and denominator we get a t raised to m plus 1. That is take in the upper, that is in the numerator. We get a integration 0 to 1. Sorry, see here some correction is there. Here we get a minus 1 by t square. The sign is minus, that's why I am interchanging the limit value. If you interchange the limit value, we get a minus, then minus minus we get a plus. Observe here, we get a minus 1 by t square, that's why I am interchanging the limit. We get a, if you interchange the limit, we get a minus sign, then minus, already is minus there, minus minus we get a plus. Then the limit interchanging, that's why 1 to 0 is a 0 to 1. The first term 1 divided by t raised to m minus 1, and solving the denominator we get a t raised to m plus n divided by 1 plus t raised to m plus n, and remaining 1 by t square d theta. Okay. See here, in denominator the second term 1 plus t raised to m plus n is as it is. The remaining part, that is the t raised to m minus 1 t square taken in the numerator. What you get? T raised to minus m plus 1. M get cancelled. We get a n plus 1. Here t square. We get a numerator. We get a minus 2 n minus plus 1 minus 2. We get a n minus 1. That's why I am taking a integration 0 to 1. The t power is n minus 1 divided by 1 plus t raised to m plus n into dt. It can be changing as a t as a x. We get a integration 0 to 1 x raised to n minus 1 divided by 1 plus x raised to m plus n into dx. See, in integration, if you change the variable, does not change the value. See here, integration a b f of x into dx is equal to integration a to a f of z into dz. Does not change the variable. It's a to b, not a to a. Okay, correction that the formula. Okay, next this will put in the equation 1 of second part. What you get? Beta of mn is equal to, first part is as it is, integration 0 to 1 x raised to m minus 1 divided by 1 plus x raised to m plus n dx, plus second part is what? Integration 0 to 1 x raised to n minus 1 1 plus x raised to m plus n into dx. Adding both, we get a beta of mn is equal to integration 0 to 1 x raised to m minus 1 plus x raised to n minus 1 divided by 1 plus x raised to m plus n into dx. It's a very important question. Okay. Next, take note. For mn strictly greater than 0, show that integration 0 to infinity x raised to m minus 1 minus x raised to n minus 1 divided by 1 plus x raised to m plus n into dx is equal to 0. Okay. We know that third property is what? Beta of mn is, that is x raised to m minus 1 divided by 1 plus x raised to m plus n. Okay. Here integration 0 to infinity. Okay. Applying the third property of the beta function. Okay. Take LHS part, integration 0 to infinity x raised to m minus 1 minus x raised to n minus 1 divided by 1 plus x raised to m plus n into dx. Okay. Separate the two parts. We get a integration 0 to infinity, first part x raised to m minus 1 divided by 1 plus x raised to m plus n into dx. Second part minus integration 0 to infinity x raised to n minus 1 divided by 1 plus x raised to m plus n into dx. Okay. We know that third property, the first term is also beta of mn, second part is a beta of nm, but using the first property of symmetric, beta of mn equal to beta of nm, we get a, both are get cancelled, we get a value is 0. So this is the proof of the example, a solution of the example. So it's the beta of the function. On next class, I will explain gamma function. Okay. If you any doubt, explain or ask in personally or in group. Thank you.